All right, next I'd like to take a look at hurricanes, and you can think of these as being huge storms that normally get their energy from warm ocean water. And oftentimes we hear about hurricanes moving from Africa across the Pacific, carried by our trade winds, and then hitting the coast, for example here in Florida, or coming up and slamming into New Orleans. And so this is kind of like Hurricane Alley, because of the easterly winds. And oftentimes these hurricanes tend to form at about 10 degrees north or south latitude. Okay? And so the necessary conditions for a hurricane are you need a strong low pressure region. And so how do you get this low pressure region? Well, that low pressure region can come from superheated air that is aloft over the Sahara Desert. Or it could be carried by the jet stream to this location from the west. But you definitely need a low pressure center, because you often hear about the eye of the hurricane. Okay, that eye and the associated eye wall is associated with a very intense low pressure region. And that low pressure region can strengthen as the hurricane gets more powerful. And so somehow you need to get this low, and that low needs to be in a favorable location. Now, what's a favorable location? Well, you need Coriolis forces. So that means that you can't be too close to the equator. Even though warm water is good for a hurricane, you also need the swirling effect that is associated with the difference in speed of the Earth at the equator versus what it is at a higher latitude. And so air that's moving in a northerly direction will tend to be deflected toward the right, whereas air that's moving from higher latitudes down toward the equator will tend to be also deflected toward the right. And so the combination of those motions together can give rise to a swirling motion about the low. Okay, so this is creating this kind of a push, but this kind of motion is creating this kind of a push, and so you get that typical counterclockwise circulation in the northern hemisphere about a low. And so those are the Coriolis forces that are necessary. And so you need to be far enough away from the equator so that you get a difference in velocity between the air that's moving at the equator and the air that's moving at higher latitudes. Remember, by the time you get to the North Pole, the air doesn't have to move at all to keep up with the Earth. And so at the equator, it's moving the fastest to keep up with the Earth. It doesn't have to move as fast at an in-between latitude. So this difference then between one side and the other of the hurricane in the speed is what gives it this kind of a counterclockwise circulation. And here the third condition, which is often met off the coast of Africa, is you need warm water. And so typically, by warm water here, we mean 80 degrees Fahrenheit or above. So this is not to say that all of the hurricanes that can affect us start off the coast of Africa. But what will tend to happen as a hurricane moves with these trade winds, these winds that are coming from the east that are driving these storm systems across the Atlantic is if the water temperature is high enough, the hurricane will build strength. And so it gets stronger and stronger. And then finally, if all of the conditions are right, it may deflect off like this and just dissipate. That would be what we call a gutter ball. But a strike would be a hit on the Florida coast or a hit, say, to New Orleans. And so that's not in a good way, of course. This is a devastating thing that can happen. And along the way here, you have Puerto Rico and Cuba. So we've heard a lot about the damage that has been done, particularly to Puerto Rico by storms in the last few years. Billions of dollars worth of damage, electricity being knocked out for long periods of time. So this is all a very disastrous kind of a problem. Now, this problem, we should mention, can get worse as we have more global climate change, because the water temperature will get warmer. And since that's the main fuel for a hurricane, we could start getting what are called superstorms, supercanes, or hypercanes. And so these things would be like regular hurricanes on steroids and would be much more powerful and much more devastating in their the results of their actions as they move through a particular area. Now, these hurricanes tend to build strength over water, but they dissipate over land. And so there was a hurricane recently that started in the Gulf of Mexico, increased in strength because the water temperature got close to 90 degrees in the Gulf of Mexico, moved across Florida and weakened, but then because the coastal temperatures here were still very warm, it built back up in strength again and then hit slowly dissipated and became just a tropical storm as it moved up through New England. And so this packed a huge punch that it tends to drop in intensity over land, tends to build up over warm water. And so what I'd like to do is show you a section of a video here that is a tutorial on the physics of hurricanes, and then I'll discuss some of the things that we see in this video.
Oh,